Hi, this is Len from Coffee Roasters Club, and in my spare time I like to design coffee roasters for my own use. I had a little bit of time recently just to kind of break the monotony of things, and went ahead and got together a bunch of extra material I had hanging around, and over the past couple weeks I've put together this 2-pound fluid bed, 220 volt AC coffee roaster, and it's almost at completion. I just have to do one more thing, and that is put a heat exchanger inside of it, which is currently drying. So I just want to do a kind of a two-part video here to show you what I've done. I don't do too many of these videos, so bear with me. What we have here is in the center part here, the bowl. That is the going to be the fluid bed area where the coffee beans are going to be roasting. And if I can ask my assistant, my wife, Cara, to give me a hand, kind of get the flashlight here and kind of point it at things, so I can lift things up here. Okay, what I have here is a top, which is basically from a crock pot. Inside is the fluid bed. Can you kind of point it in there a little more? Bring it down a little more. So what I did was I have, as you can see, 3/16 of an inch diameter stainless steel caging around a bowl, which I put a kind of a funnel down in the bottom myself, kind of make it more funnel. And around the edge, right here, there's an insertable de-chaffer ring, which has very fine holes in it. Let's see if I can show you the fine holes in that. Maybe not. Can you hold this for a second, please? Maybe I can lift it out a little. It's a little difficult to show on the video. There we go. So that kind of sits inside the bowl, outside of the inner bowl, and outside of the 3/16 of an inch diameter stainless steel. Inside this tube here resides about 3/4 of an inch above the very bottom inlet. These things are a little difficult to show because of the lighting, but maybe you can see in the very bottom of this funnel that I have in here, I have 5/32 of an inch stainless steel, which is where the very hot air is going to come through, lift up the beans. And this container here, this whole setup, actually will hold 2 pounds of green unroasted coffee beans, and it's good for up to a city roast. If I want to do darker roast in a city roast, it's good for up to 1 3/4 pounds because of the expansion of the beans. So we have that. Now if I can ask Cara to hold the flashlight again. And this is a little bit of a unique design. I don't know if it's actually my original my design, but instead of having an air blower, air vacuum motor, which is this thing right here, instead of having it blow up under the bean bed, this acts as a suction device, causing negative air pressure, which actually, as you can see, it's negative air pressure. It's pure suction through the roaster. The exhaust gases actually exit what would be the conventional side of the blower through this high temperature reinforced, silicone reinforced tube. And at the very end, Cara? At the very end is a nozzle. Can you point at the nozzle? Which I put into a little thing that goes outdoors. A lot different concept than the typical fluid bed roaster. The advantages that I have seen, that you don't have any roasting smoke leakage at all throughout the whole unit, and I believe it makes for a more compact unit. getting back to now a little bit of the mechanics of the roaster. In the roasting process, what we do is, again, we fill the beans up in here, we put beans in here, then we get this lid, we put it on top, okay. As you can see, there's a silicone rubber area around the top, which provides a good seal when the vacuum starts. Then we turn on the exhaust, which provides the suction of pulling the air through the bean fluid through the bed, causing the beans to spout inside this glass top. Here, just when I just point there. To turn it on, we have a PID. I turn the PID on. I set the PID right here to the temperature I want to achieve, and also the amount of time I want to achieve that temperature, and this roaster will do it. So this roaster will do 2 pounds to a city plus roast in 11 minutes. Not even sooner than that. Okay, this roaster again is 220 volts. So I have in back here, you'll see a covered kind of chamber type thing. There's two 1,600 watt heat gun elements facing downwards on that side of this bottom chamber. There's one 1,600 watt element facing down in here. Now, this very bottom is a mixing chamber. So the air comes through here, comes through the heating elements, goes down into the bottom chamber here on both sides. All the air, of course, is superheated at this point, goes up through the fluid bed. You know, the spout's going to happen. We're going to show a complete demonstration later. And on the very back end of this, what we'll see here, if I can get some kind of a picture, is another little, you see a little connection right there. That is the hot air that is coming out of the fluid bed. And now we look inside, we see a disconnected hose. What is going to be in that place right there is our heat exchanger, which is currently drying right now. What we have is a special heat exchanger that I designed. I got some pointers from Old Gearhead on homeroaster.org, OGH also. I want to thank him for his input. And what we have here, hold on one second. Let's pull the plug. In the wall. No, in the wall. Wall. Top one. There we go. That's my pneumatic rivet gun. Excuse me for a second. Okay. What we have here are, you'll see two 6-inch diameter end caps, which are adhered on each side with a 6-inch diameter aluminum cap. We have a little chamber here and a little chamber there, and then connecting the two chambers are 44 1¼ inch diameter outside diameter copper pipes, copper tubing. This is going to sit in between those two red hoses, and up above it, as you'll see there, is an inlet. So this roaster here is also going to be pulling air through the front. This is the front plate, which has two fans in it. It's going to be pulling air through all this tubing. It's going to pull it in through all this tubing, and the hot air is going to go inside of that tube right there. And as you can follow the track of that tube, as you'll see, that tube right there with the holes in it goes right into the roaster. We have a temperature dial right on top, which is going to provide the inlet temperature. So I'm hoping that this is going to make it a more efficient unit. I mean, it can only be more efficient because it's going to recirculate that high temperature exhaust air. No exhaust air is getting inside this chamber. What's happening is the exhaust air, all exhaust air is flowing through these little copper pipes, then getting sucked into the vacuum unit there at that point. Remember, it's going to, that heat exchanger is connected between these two pipes, and I'll show that later on in the video, and then it goes out. Here's all the electronics for the PID system and the heaters, and also, so let's make believe that we're doing a roast. We set it for 435 degrees, which is typically the end of City Plus. The roaster's cranking away. All of a sudden, it hits 435 degrees, and I want it to go in automatic cooldown automatic cooldown status, I guess you call it. What happens at that point is the heating elements turn off. The exhaust is still on. Now at this point, I want to cool down that bean mixture as quickly as possible. So what I need to do is I need to cool down that exhaust as rapidly as possible. Now, since the exhaust is still going, it's going to be recirculating some of that exhaust. Of course, it's going to be recirculating some of that heat from the exhaust going out because of the heat exchanger. So what I want to do now, I want to provide a large volume of air to enter this chamber, to blow heat off of the heat exchanger. And what I have this set up as is when the heaters turn off, I have a relay set up in here that recognizes that the PID has told the SSRs to turn the power off to the heating elements. It recognizes the power is now off. At that point, it kicks on these two 85 cubic foot a minute little muffin fans, which is going to blow outside air in through here, going to blow it across and through the heat exchanger copper tubing, and it's going to blow out the top right here, hit a little flap, and there's holes underneath. So hot air is going to start blowing out of there. So it's going to cool it down more rapid than if it just was using the air getting sucked through with the heat exchanger. The heat exchanger is still going to be sucking air through because of the exhaust suction, but it's going to be vastly cooled down because of the extra air flowing through the unit. Now, it gets a little complicated. I would say probably about 6 or 7 hours from now, this whole heat exchanger will be dry and mounted inside the roaster, so we can give it a try. I've already roasted beans in this without the heat exchanger and without the PID, so I know that it's functional and that it does do 2 pounds. What we're going to do is we're going to be roasting to a city roast. We're going to be mixing we're going to be roasting a breakfast blend that I've developed. So again, this is a 2 pound electric fluid bed coffee roaster that we developed ourselves here, and it's 220 volt, and this is something that if you're going to be working with this kind of a voltage, you should have some experience definitely working with electricity. This is not something for a beginner. You should definitely observe, of course, all safety precautions if you manufacture or copy anything I'm doing here. I'm not going to be selling this unit. This is just for our own use. So maybe there's some ideas in here that you can gloss from, but again, it's very high voltage, and I've been doing coffee roasting manufacturing for going on 13 years now. We've been doing a lot of stuff like this, so it's a fun project to do for us. It is complicated, And again, we'll have another video for you later on to look at. Okay, bye. Hi, this is Len again. My wife Cara and I just got done putting in the heat extractor, heat exchanger, and it was challenging, that's for sure. It's connected solidly in here, inside of the 2-pound fluid bed coffee roaster. I was going to explain maybe one of the only negative aspects I've seen about the vacuum type, negative air pressure fluid bed coffee roaster, where it's actually sucking air through the beans, sucking air through the whole coffee roaster instead of pushing air through the whole coffee roaster, is that the vacuum can get a little bit hot because of the roast air that's going through. Now this heat exchanger right here is going to shed lots of heat because of how I designed it, and my speculation is that the air that exits through the vacuum and through this hose will be well within the tolerances of the motor itself. I had this running before without the heat exchanger, with a little bit different kind of heat shedding system inside the roaster, where it was just basically this silicone tube, but quite a bit of it coiled around inside of here, and the vacuum worked fine. It did get hot. This hose here throughout did get hot, but well within the specs of the hose, and apparently the vacuum too, because it didn't fail. But still, you want to have it as cool as possible, and I believe this will definitely do the trick. In addition to recirculating the shedded hot air from the exhaust going through these little tubes, going back into the roaster through here. And again, we have the temperature dial here up on top, which is going to tell me at what the temperature of the incoming air into the roaster is from the from the heat exchange device. Again, we have 1,600 watt heat gun element going into this side of the mixing air chamber on the bottom, and 2 here on the other side. We decided that we're going to let this all settle for the night in case there's anything that still needs drying. Just to let you know, I used actually a high temperature white paint, spray paint, for sealant, to seal the pipes in the 1/4-inch holes as they go inside the 2 little kind of chambers inside the heat exchanger. This being, I can't really point, this one here being one of the chambers. This here is another chamber. So basically the hot air comes in right there into the heat exchanger, goes into there, into that little chamber I made. Gets broken up into 44 different segments because of the 44 different copper tubings, 1/4-inch tubing. Goes into that on the end, that chamber on the end, then goes back into the single, I don't know what it is, about a 1 3/4-inch silicone high temperature pipe, reinforced flexible pipe, into the vacuum motor, and again exits out through your wall outside. On top again we have 3 switches. I don't know if you can see them well. One's the exhaust, the other's the PID, and the other one is the heaters. I have a separate heater switch which is connected to the 2 SSRs, so that I can set the PID with the exhaust off without the heaters on, so that the heaters don't get burned out without air going through them. I want to do my initial settings of everything, which I haven't actually done yet. So we're going to let that sit overnight, I made a little bit of a support, even though it probably doesn't need it, for the heat exchanger right there. The heat exchanger probably weighs about 7 pounds, possibly because of all the copper tubing. And we'll see how it all goes tomorrow. Thank you for joining us. Again, Len and Cara from Coffee Roasters Club. This is their own personal coffee roaster we made in our spare time. Okay, bye. Hi, this is Len from Coffee Roasters Club, and we're here. My wife Cara is the one that is recording this. We're going to do a test of the 2-pound fluid bed coffee roaster that we developed. As you can see over here, it's plugged into the 220 volt dryer outlet, and I made a couple modifications. We did a test last night, and I have a cooling mechanism that I developed right here. When it is time to cool the beans, I just raise up that flap, and it's one on this side of the roasting chamber on the bottom, roasting mixing air chamber, and there's another one on the other side too. Here's 1 pound 9 ounces of a breakfast blend mixture that I've put together, and at this point I'm just going to dump it right inside the roasting chamber. Try to evenly put it in without it. That should be good. Just kind of take a little bit out of the center tube, get it out in the main chamber, holding chamber, whatever you want to call it. That should be good. At this point, I'm just going to go ahead and put the lid on top of the roasting chamber, making sure that it's nicely sealed all around. It seems to have done it. So if we go over here and look at the PID, can you zoom in on the PID? Currently at 65 degrees ambient temperature. I have the PID programmed with auto tuning to achieve 420 degrees Fahrenheit within 11 minutes. At that point, the PID will turn off the heating elements, and I'll lift open the doors down here to let cold air in, and likely the bean mass will still rise in temperature for a moment. I'm hoping for it to achieve 426 degrees ultimately before it stops dropping down. And I'm hoping that it drops down fairly rapid. There is a lot of heat involved here, and I want to try to do this like an all-in-one system where it dechafs it and cools it down rapidly too. The noise you hear in the background right now is our pellet stove, and there's nothing I can really do about that. So at this point, well, let me back up a little bit. Yesterday, we didn't use the auto tuner. We had it more set for a traditional completely on, completely off mode, where the PID would either turn off or turn on the heaters without auto tuning. And this is really the first time I've going to be using this auto tuning feature. Yesterday, it did not hit the desired temperature of the bean mass before the time ran out, so it stopped at 400 degrees. And it did 11 minutes, and it was 400 degrees bean mass temp, and I wanted it to be 426. So after some adjustments, I got it going again, and then I overshot the mark, and instead of ending up with a city roast, I ended up with a full city plus roast for my breakfast blend, and I didn't want that. So hopefully we'll be able to achieve our goal today of 11 minutes at 420 degrees then start the cool down, and at that point again it'll probably rise up about 6 degrees in the bean mass until it finally just straight goes down. So at this point right now, I'm going to turn on the exhaust, get that bean mass lifted up. Can you point on the side? Can you see it good? Okay, I'm going to turn the exhaust on. You should see the bean mass start. Okay. That's interesting. I believe I have too many beans in the center chute. To get the bean mass flowing right off the bat. That might do it. Okay, let's try this again. These are all the little trials and errors that you encounter. Alright, here we go again. Yesterday, I was doing a little more. Mostly because of the doors I put on. No, I shouldn't do it. Okay, we're going to start the heaters right now, see if it has an effect. And I'm going to start the PID function now. Doing mostly the auto tuning thing. Like I said, I never used the auto tuning thing before. I'm not getting anywhere near the lift I had yesterday. I don't know what the problem is. I shouldn't be able to do that at all.
Yeah.
Something's not right. Hi, this is Len, and my wife Cara and I are here to again test out our 2-pound fluid bed coffee roaster. It runs on 220 volts AC. and as you can see, it's hooked up into the dryer outlet we have. And we have 1 pound 9 ounces in our roasting chamber, and it's a breakfast blend. And I wanted to get to be a city roast. I made some adjustments. Put on some cooling tamper things that we're going to use at the end when we want to cool the beans. I'm going to lift them up at the very end to rapidly cool the beans down. I have the PID set for 420 degrees, and it'll probably rise up a little bit above that to achieve a city roast. I'm using an auto tuning feature called the auto tuner on it, and so I don't really know how well this is going to work with the auto tuner. I've never used it before, so we're going to first try to get the bean some point it's going to go ahead and get done with this auto tuning. I really don't know how long it takes for it to do its deal. I've never used this before. See me doing too damn much to me.
You should set it higher than 65.
No, it's set correctly. ridiculous. Doing a damn thing. I'm going to set auto-tune to something different here. Heating elements definitely turned on. We got fluid bed action. Well, let's ride this out. See where we go. As you can see, the fluid bed is working now because heat's going through and God only knows what's going on. Alright. It's still supposed to be auto-tuned. You can see the temperature here. Imagine at this point I can grab a hold of this from my wife's car and... Alright. Well, it's all an adventure. I gotta learn more about auto-tuning. It's not... As you can see, I'm getting some pretty good spout action here. Both feeding elements, you see these feeding elements in back. Back ones are on, front one is on. I've got the recirculated hot air mixer from the back going through. Working better than yesterday. Yesterday it said 136 on the bottom, 149 on the top. The heating elements would have been off, and that's why it stopped. I think during a certain point. Back flap opened up. That's because the exhaust is hot, the elements turned off because it's just getting really hot there, and the PID decided that it was time to turn off the heating elements, and when that happens I want to try to keep that exhaust that's going out as cool as possible. So we go, and the front fans turn on at that point right here, causing to ventilate out some of the heat. turning on when it's like that. It's odd. The heater's turned on again. As you can see, I'm not getting the fluid bed action that we got yesterday. I don't know why. There's a lot more fluid bed action yesterday. Wondering if it's because of the heat extractor I put in. I wonder if the tubes are clogged with the coffee oils. Could be. Still climbing. Says you can start the auto turner anytime by hitting the AM key. I don't know about that. Doesn't seem to be doing much to me. Ooh, looks like we got a heating element that's blue. Oh, that's great. Oh, that just kind of did that, didn't it? Heating element blue already. Well. Hi, this is Len and Cara from Coffee Roasters Club, and we actually found, after doing a test, that the initial heat exchanger that we put inside the roaster, the one that's going to be pulling heat off the exhaust and back into the fluid bed roaster, was not the best design. It was too intricate, the tubing was a little bit too small, it didn't stay together correctly, so we made a little bit less glamorous looking design, but I think it'll be more functional. It's basically has 3/4 inch copper tubing going right through the center of the heat exchanger, as you can see, And the center part is just a cylinder that I made, and we painted flat, high temperature black, and we made sure to burn the paint off, do an initial burn with it prior to putting it in the roaster to get on any kind of smoke that would have emanated from the paint off, because it's going to be recirculating back into the roaster. We didn't want that to happen. So as you can see, the pipes get really close to the back. You see the little holes right there inside that tube that goes across. That's the inlet tube that brings air back into the roasting chamber right there. So that tube goes into that high temperature silicone tubing back into the roaster. I made little inlet valves here for the very end of the roast when I want it to cool down fast and after the heating elements are turned off. So it should work pretty good. We already did an initial test when it comes to the actual being able to pull the beans up quickly, and it does. We're going to do a little bit of an initial roast, take care of some beans that were half roasted last time, and then we're going to do a full roast and do a demonstration for you, show you how this whole thing works. Okay, bye. In car of Coffee Roasters Club, and we're going to be doing another test of our 2-pound capacity fluid bed coffee roaster. Been making improvements and adjustments over the past couple of weeks that we've been testing it, and setting up some new things too. We're going to be roasting about 1 pound and almost 1.5 pounds today of Dominican Bani, B-A-N-I. I think that's how it's pronounced, as Bani. And we're going to be bringing it up to a New England roast, and that means that the bean mass temperature is going to be reaching 401 degrees. It's going to be going just a little bit into the first crack. So I'm going to be mixing this with a darker roast to make a special black and tan that we do. But I have an interesting little experiment we're doing. You see this little apparatus I have here that's going into a bucket. This is actually part of an air intake that I'm going to use at the very end when we cool down the beans. And it's, I would open up the air intake by opening up this valve. What's going to happen is at the very end of the roast, when the elements, when we turn the elements off, we want to get the beans inside here as rapidly as possible down to ambient temperature, which is about 60 degrees. So what I did was I fashioned a hose that goes into this bucket. On the very bottom of the bucket, about 3 inches above the bottom, I have a stainless steel screen. Basically it's 20 gauge stainless steel with 5/32 of an inch perforations. And I filled the bucket up with these ice bricks, which are basically gel refrigerant packages. They're food safe. Just saying that there's not going to be any mixture of this with the beans. It's just I'm using it instead of a bucket of ice cubes. And what's going to happen is it's going to draw. Air is going to be pulled down through all of the gel packs, and it's going to be below freezing or freezing, and it's going to suck that really cold air up through this tube and right into the mixing chamber where the air is all mixed in with, generally speaking, with the heat. This is from the heaters, but the heaters are going to be turned off. And it's going to go up through the bean mix, cooling this down rapidly. It's going to exhaust it out. So, a little bit of a summary again how this roaster works. We have 3 1,600 watt heating elements. There's 2 here, and there's 1 here. Air gets drawn through them, through the 3, into this mixing chamber down in here, which is insulated with ceramic insulation. Superheated air gets blasted up through the beans, and there's this, we use the fluid bed spouting action method. The exhaust is of course sucked through. There's a special cooling chamber inside of here that cools the exhaust prior to its exiting through the vacuum system that we have, and it just gets shot, the hot air and the exhaust just gets shot out through that thin tube outside. Here's our PID. It's programmed to get up to 300 degrees in 5 minutes, and that's so it goes through a type of drying phase that's a little bit extended, and then from there it's going to take 5 minutes to get up to 401 degrees, and at that point we're going to it'll automatically turn off the heating elements, and at that point we start the cool down process. Now, we've had some issues with the heating elements burning out, and I believe it was caused by a heat exchange unit that we had previously, which was cutting down on the volume of air actually going through the heating elements, causing them to superheat and burn out. So we lessened the amount of volume of air going through by taking out the heat exchanger port and substituting it with this special cooling down system, which is turned off now. And I'm hoping that combined with a couple of adjustments I made in the PID is going to stop the heating elements from getting fried. So first thing I'm going to do, I'm going to turn on the exhaust. The PID is all set to go. After I turn on the exhaust, see that the spout is working, I'm going to start the PID, and then I'm going to flip the switch that allows the energy to go to the heating units, and then we're going to see how it goes from there. So I'm going to turn the exhaust on now. There's the spouting action. I'm going to go over here. I'm going to start up the PID. Turn on the heaters. They're heating up. They all look okay. So far so good, the heating elements are working properly. Cross my fingers that these darn things don't overheat. far so good. The elements are behaving. It doesn't mean they're not going to blow out. Well, there they go.
Get it off. Get it off.
Trying. It's hot, man. Coffee Roasters Club, and we're going to be doing a good test here of our 2-pound fluid bed coffee roaster. We're going to be roasting 1 pound 10 ounces of a breakfast blend that we created. We're going to be roasting it for about 11 minutes, and we're going to achieve a temperature of 426 degrees bean mass temperature. And I'm going to be going all through this with you. You've seen some parts in the video, and we finally come to being able to make the roaster work very well. Excellent, in fact. I added on a new switch, which is a variable rate switch for our exhaust and bean loft height, and it works excellent. I'm going to start by programming the PID for the city roast. So what I do here is I just turn on the PID, and PID itself goes on. I'm going to be adjusting what is called an output wattage percentage for the 3 heating coils that we have here. So what I do is I go over to the PID, and this is a ramp soak feature PID from Behrens Instruments. I go over and there's a little button that says set, and I hold that button in until I see an alarm function up here, and I keep pressing this until I see OUTH, their representation of OUTH, because it always looks funny on these things. There's OUTL and there's OUTH. It's at 70%. So what I'm going to do is I'm going to bring it down to 50% for starters, and I can always adjust it on the fly, you know, going back. And when you're done, you just take your hands off it, and it'll revert back to the initial settings. You can see it says stop. That means that the program is not running and the program has stopped. Now what I do is to set the temperature and time. I now go to this little button that says A/M, and I hit it once. And then you see a C and a 01, and what that 61 represents is our ambient temperature. It's about 61 degrees down here in the basement right now. I'm gonna have to hit that again because it reverted back. So that's good. Now the next step is time, and this 5 minutes, but it's not 5 minutes at 61. It's 5 minutes at the next step in this procedure. It stopped again, as you can see. It reverted back, and that's fine. So what I do is there's C for 61, ambient temperature, 5 minutes. Now it's C02, and that's 300. That's 300 degrees. The 5 previously, the 5 minutes, is what I want to have as the time for 61 degrees bean mass to get up to 300 degrees. It's considered to be a little bit of a drying out period. It's fairly important with an air type roaster, because air roasters have a habit of roasting very quickly, and they can sometimes hit first crack so quick that there's more of an advantage to slowing it down. So let's go back there again. 61 degrees ambient, 5 minutes to get up to 300 degrees. Now the next point is 6 minutes. I want to have 6 more minutes to go till it hits 400, not 435 like I had it set previously for a City Plus roast, but 426, I believe. 426 for a City roast. And then the next step, the next step is a time setting of negative 121. Now that specifically tells the PID to shut the program off. So let's go through that again. I hit the A/M. I get the temperature I need to set is 61. Like I said, it's 60 or 61. 61 is ambient temperature right here. Okay? Well, now that that's done, I hit the next button. That's 5 minutes for T01. 5 minutes to hit 300 degrees. Now it's after it hits 300 degrees, I want it to go 6 minutes till it hits 426. And then after it hits 426, I want the program to say stop. The program now, once it hits that last step of the negative 121, again, the negative 121 is a specific number that is programmed into the PID, so that the PID knows that once it hits that step and it says negative 121, that'll say stop, which means that it'll turn off the heating coils completely. Once it hits, that temperature, I'm gonna flip the heating coil switch down myself, just as a precaution. I'm going to open up this valve right here, which will pull very cold air from this bucket full of ice bricks. It'll pull all that cold air and air coming through the coils, which are now turned off. These are coil inlet. Air goes right in through here. Mixes it up all down the bottom chamber here. And, as you've seen before in the video, the bean spout goes through nicely. And I can even open up these bottom intake things here for the cooling cycle if I want to, and sometimes I do just to play around. Okay, there's the PID. It's ready to go. Here is our bean mix. It's 1 pound 10 ounces of our breakfast blend. It comprises itself of 4 different single origins. We have a North American region origin, we have 2 Central American origins, and we have a Caribbean origin. So I just dump that right down in here. Kind of take a little bit of beans out of that center tube. I get our cover. Put on nicely, so make sure it's all sealed around. and it is. Now I just go over here. This way. I'm going to step in front of the camera. I'm going to turn on the exhaust. Initially what happens is, because I have the actual exhaust vacuum hooked up to this variable rate, nice variable rate switch I have. We have two fans here that suck air into this whole electronic filled chamber, and there's also a canister in here that has tubes going through it that the air goes through those tubes and cools off the exhaust prior to it getting sent outside. It's nice to cool down the exhaust as much as possible because we want to keep this nice vacuum that we have here. These vacuums here are brand new. It's a special type of vacuum. Actually run around $900. I didn't purchase it for that. I purchased it used, but brand new. They're $900. They're actually units that they use in hospital beds that allow the bed to rise and lower and do all kinds of things. But for our purpose here, we're using it as a type of system that creates negative pressure inside of the bean chamber to allow the beans to do their fluid bed motion. So here we go. I'm going to turn it on. Nice fluid bed motion there. I can adjust it as it goes. You know, in fact, I'm going to start this off at 45%. 45% when it comes. We'll try 40%. We like to keep the heating elements as low as possible when it comes to the water. This makes it more efficient. We'll try 40% on them. Okay, at this point I turn the heater on, the heater switch. That means that we're all set now to start the program, and boom, the program's going. As you can see, the bottom is counting up, so the heating coils are going to try to try to keep with them. The heating coils are all on, as you can see. They're at 40% wattage. We have a little catching up to do, so I'll turn that wattage up a bit. About 20 degrees difference between the bottom and the top now. Actually between what it should be and what it's being. It's starting to catch up a little. Adjust it a little more again. starting to catch up. Only about 10 degrees difference now between the what the PID wants and what the bean mass temperature is. We'll do it even a little more here. Put it at 70% like it was before. I probably should have started it at that. So we'll let them experiment with the new variable rate fan thing. Catch up. I think it's catching up now. Well, we're going to have 4 degrees difference. Went through the drying phase. Yep, here we go. About ready to meet. That's a nice velocity we got. Yeah. You can see the heating elements went off for a couple moments. We're doing so well. Keeping up here. Still doing very well. Kicking on now. Off now again because the plays catch up with itself. I'm fairly confident that'll hit its mark well. Still 10 degrees off. Let's see. Catching up. Catching up good now. About 5 degrees off right now. Want to get to 426, it's at 406 degrees bean mass temperature. You see how the beans are expanding inside now. Still about 4 degrees off. 3. Put it up to 75%. Whether that makes any difference or not. Okay. Almost there. 420, and we're there. Alright, we're cooling down the system now. The temperature starting to drop. We got over to 429, but temperature's dropping, as you can see now. Going down to the cooldown period now. We're still right around the area where first crack stopped. Oh, excuse me, where first crack is just finishing. So we got a city roast. Definitely got a city roast. That was what we were hoping for. Again, it's full of cold air from the bottom, and exhaust is up to full speed right now. It's nice that we have this variable rate exhaust system. It's electronically controlled right into the motor of the vacuum. Not your typical variable rate AC device. It's actually a DC device. It varies the DC voltage from 0 to 9 volts DC. And that's feeding a signal, the voltage signal of such, into the electronics of that vacuum motor. The vacuum motor itself has electronics due to the fact that it is used in the health industry, again, for raising and lowering and working with hospital beds. So it's nice that we have this variable rate, because when you get to the very dark roasts like a French roast or a Italian espresso roast, those beans are very delicate, and if they have way too much agitation at the end, this thing provides a lot of agitation, as you see, inside that bean mass. Inside that bean mass, you can see there's a lot of agitation in there. If there was that much agitation, it would actually shatter the Italian espresso roast or French roast. So that's why we have that. The thing worked pretty much flawlessly this time. For the past 2 times it's worked flawlessly. We just overshot the 426 mark by a tiny bit, but it didn't get into the City Plus roast. We're aiming for the City roast, and we did get it. It's going to be a delicious breakfast blend. Alright, we're down to 288 degrees bean mass temperature. I don't know how many minutes have gone by. This is the fastest that we can get it to cool down. And I just play around with it. Every little bit helps. That's why we have the ice bricks. These are frozen ice packs that we picked up on Amazon. We just put them in our freezer. Again, this is the inlet tube here that pulls air from the very bottom of the bucket up. The air comes down into the ice, goes down to the very bottom of the bucket where it's collected by this tube. Cold air comes right in through this whole apparatus and gets all pushed through this bean mix that you see and cools it down as rapidly as possible. Like right now I put my hand on this metal. The sides are insulated, but of course the top I couldn't do it. But before, that metal would have been over 500 degrees, I'm sure. Next time if I start with this many beans, pound-wise, I'll probably start at the 70%. I'm just playing around because of the variable rate fan. You can look real close inside here. See if I can. Right there. The focus is to that glass. You see a clump. Whoop. That's all chaff. It's not clogging up the air because the chaff collector goes all the way around the circumference. It goes all the way around the circumference of the bean chamber container, right outside of it. So this can get clogged up. It can get clogged up. I mean, get full of chaff right up here, but the air exhaust will always pull through and allow the beans to be lofted because of the design of this. Alright, we're down to 172 degrees bean mass temperature right now. I'm going to get it down to 90 degrees and then we're going to take the beans out and show you how wonderful they look. Since it's a city roast, I can have the exhaust all the way up. The City Plus roast I can do too, and a full city. When it gets into the full City Plus, that's when you start wanting to really lower the agitation. So when you lower the agitation a little bit, that means that less volume of air is going through the bean mix. So it does take a little bit longer for the beans to cool down. At any rate, I first designed this to be a 2-pound capacity, And it will hold 2 pounds of beans roasted if you're doing a city roast. Start getting heavier than darker than a city roast. The beans are expanding more, and the volume of beans, will increase. So if I'm trying to do, I only want to do about 1.5 pounds unroasted beans. If I'm even less than that, maybe if I'm doing an Italian espresso roast, they get really big. Their volume really increases. Alright, we're down to 120 now. I sometimes pull around and open up these side doors here. I have one in the front, one in the back here too. Just pulling around to see if it has any kind of an effect on maybe decreasing the temperature even faster. I don't know if it really does or not. I mean, when you open up these doors, it decreases the volume of air coming through the ice pack pores in here. It's something to play around with. What I'm going to do, I just want to close it up. Here's the back door. You can see the same thing as the front. We designed this completely from scratch. It's a prototype, just for our own use. I wouldn't be selling it on the market or anything like that. It's just, since it uses 220 volts, I'd rather stay away from the liability of somebody electrocuting themselves. People like to open up things and play around with things, and 220 volts is nothing to play around with. You gotta really know what you're doing. So in the open heating elements right here, it's fine for me because I know what I'm doing. But having an open element thing like this for consumers would be a little bit too risky. Alright, so okay, the beans are ready to pull. So that bean mass temp is now 88 degrees. Turn off the PID. Turned off the exhaust ventilation. Turn off everything basically. We come over here. I'm going to take the lid off here and show you how wonderful these beans look. As you can see, they came out really good. Got 4 different single origins in here, so there's going to be a tiny bit of maybe color change or difference between them, but they're actually very, 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 very evenly roasted, especially considering it's a City Plus. Remember, City Plus roast is one of the lighter roasts, and sometimes it likes to be a little mottled in look, or maybe a little more uneven, only because it's just not to the stage where they like to pull complete evenness. So I'm going to hand off the camera to my wife Cara now, and we'll show you how we get these beans out of here, because you can't remove this. So we've devised a pretty ingenious way of getting these beans out, and it works great. So here we go with that. Got it, Cara? Mm-hmm. What I have here is a food grade plastic container that you could open and close. What I did was I got the end of a vacuum tube and I cut it so that this pokes its head right through a little bit. Got a little bit of super glue around the top, and then I put a hose clamp in the center just so it doesn't pop out. Now here's the neat part. If you look inside here, you can see that good? Inside there's a screen, and it's bubbled up from the bottom. And there's a hole in the bottom of this container. And as you can see, that screen is stainless steel. You can see chaff inside here from previous use. And that's riveted on the bottom. And there's a little bit of silicone seal around the inside ring of that, where it's riveted, and then I riveted it, pulled it through. What I do is I get another hose that we got. It's a regular vacuum hose. Again, another end of the vacuum hose, and this just slips right into that, like that. And you got the other side, which is one of the type of attachments you get for your hoses. And then I just attach it right on there with a hose clamp. Screw this onto the top like that. There, it's sealed. Now we go with this nice vacuum that we only use for this application. It's nice and clean. Just stick the hose right in the bottom like that. It fits snug. What this is going to do is it's going to create a vacuum course. All the beans are going to get sucked up out of there, and they're going to end up in this container, and I'll just take that nozzle off, and all the beans stay in there because of the screen. So here we go. Want to get a nice close up? Get it good? Little stragglers there. There you have it. All the beans are inside there. Just like that. What I'm going to do is I'm going to set this on top of the roaster, and hopefully it won't fall off. Unscrew the top of this. Dump the beans. Just roasted beans right in there. There we go. And we we started 1 pound 10 ounces, so it'll take about 20% weight off of that, if that. And that's our breakfast blend, City Roast. Smells nice. Of course, it has to degas. But what I'm going to be doing right now, because we have so many beans, we've been experimenting, I'm going to bag these up and put them in the freezer. When I want to use them next, I'll just take them out and drink them up. Thank you very much. Hey, it's been great. I hope that been able to show maybe some new innovations here. And like I said, we're not going to be marketing this. We have no intention to. Maybe there's a couple ideas that you can glean from it, especially the neat little, bean evacuator for your roaster. And it's been a lot of fun. Have a good day. You wanna take care of the? What was I gonna say? Can you give me one of those 5-pound bags again?
Kaiser. Hi, Kaiser. You're so cute. I'm making a video of Kaiser. Maybe love for the camera. Yes. Is that your towel? Is that your towel? Oh, whip that towel. Yeah, whip it. Show off.